Okay, let's take a look at lesson 423. We are looking at unit, rate, and proportional equations today. Our focus is what happens at a yogurt shop. So we have a person named Jill E. Bean that owns a local frozen yogurt shop. At her store, customers serve themselves a bowl of frozen yogurt and top it with chocolate chips, frozen raspberries, and any of the different treats available. Customers must then weigh their creations and are charged by the weight of their bowls. Jill E. Bean charges $32 for 5 pounds of dessert, but not many people buy that much frozen yogurt. She needs your help. She needs you to help her figure out how much to charge her customers. She has customers that are young children who buy only a small amount of yogurt, as well as large groups that come in and pay for everyone's yogurt together. All right, let's analyze this problem using these questions. Is it reasonable to assume that the weight of the yogurt is proportional to the cost? And I'm going to say yes. And usually yogurt is sold by the ounce or pound. If we assume that it is proportional, we have a table here that lists the price for at least 10 different weights of yogurt. And I have included 3 weights that are not whole numbers. So to begin this, I need to try to figure out my unit rate. And in order to do my unit rate, I take the things that I know, $32, and I'm going to divide that by 5 pounds. And you'll notice 6.4 or 6 and 4 tenths, but I'm going to write that as money with 2 decimals. And the easiest way for me to use our time efficiently is to use this calculator. And with this calculator, I am going to divide this in half. And that's going to give me how much it costs for half a pound. So for half a pound is going to be $3.20. If I divide this in half again, that gives me the cost for 1/4 of a pound. And to get the cost of 3/4 of a pound, one thing I could do is add these two together. $3.20, $1.60 gives me $4.80. Oops, make that our dollar sign, $4.80. And then if I double this, many of us can do this in our head. So this would be $12.80. If I want to make the next one happen efficiently, we're going to go back to the calculator, and we can do 3 times our unit rate, which is $6.40, and that gives me $19.20. And to get this right here, I could double at 25.60. For this one, I'm going to end up doubling this one because 5 times 2 is 10, 32 times 2 is 64, and I can double this again to get $128. And that might seem like a lot of money, but sometimes large groups go in after an athletic activity or some kind of other group activity, and they might be buying a little bit more frozen yogurt than you or I alone might buy. So we have some questions to further analyze this information from the table, and it asks us in letter C, what is the unit rate of the yogurt? Stores always also call this the unit price. And the unit rate of the yogurt we found was $6.40. And we could write an equation for this by saying cost equals 640 x. Why x? Because x is going to represent the weight of our yogurt. So we can put a little x here, and y is going to be our cost. If Jill E. Bean decided to start charging 50 cents for each cup before her customers started filling it with yogurt and toppings, could you use the same equation to find new prices? Because she's doing something different, we would have to say no. Why or why not? She is adding something to the situation. So the equation would have to change. Or she could make a sign to show the cost of the cup is being added. All right, so there you go. Let's put this back up here so you can see that. Stores want to be as transparent as they can with their customers so that people feel like they're getting a fair deal. And that's why we would want to make sure we were clear on that. And so now it's time for you to work on the independent student work for today, moving more into unit rates and proportional equations. So using something that we learned in the past, applying it to today's lesson, and moving on into next week's lesson.